This is the third international webinar of Moscow Mac Center. We today have a very interesting speaker, Yuri Pavlov, who will present EEG mini labs project. Yuri graduated from Tuebingen University, or he graduated from Ural Federal University and obtained PhD from Tuebingen University. And now he is a postdoc at Tuebingen University and senior research scientist at Ural Federal University. And he is interested in working memory, classical operant, I don't remember, some conditioning, and also consciousness, and he's now very active in this research. But most important for us is that he's a leader of this very interesting international multi-center project. And before he will start, I will kindly ask you don't switch on microphone during the presentation. It will be not very long, and we will have a lot of time for questions and discussion after the presentation. So you can write your questions in the chat, or probably also will have opportunity, if there will be not very many questions, also to ask just using microphone. And so, actually the webinar is recorded and it will be on YouTube. So please keep this in mind. Okay, so now, Yuri, please, let's start.
Okay, thank you for inviting me to this webinar today. So I'll share my screen first. And you can see my presentation here. In this talk, I wanted to tell you more about the EEG mini labs project we started a couple of years ago. Still work in progress, and I can't present any results yet, but what I can do, I can present you our plans and what we're going to do in the next couple of years. If you're interested in the project, you can go to this link and it will lead you to our OSF page, where you can find more information about the project, such as how to join it if you like. You can see the list of studies we selected for the replications, and some other information is available there. But I will start from the motivation, what actually led to the start of this project. I think I should not tell you about EEG, what the EEG is, because I think most of you have been doing some kind of neuroscience research and well aware of electroencephalography, and it's been around for almost 100 years, and it is basically one of the most widely used approaches to examine brain function. The thing is, with EEG, as well as with any other neuroscience method, the data is rich. You have lots of data points, you have lots of channels, and the research is more expensive than, for example, experimental psychology, behavioral research. Most researchers just tend to test novel hypotheses in small samples in these highly multidimensional data sets. But not everyone is keen to replicate their own studies or the studies of previous researchers, previous studies. Basically, the data on replicability of EEG findings is very limited. And a couple of years ago, around the Christmas time, I was sitting at my desk, just looking at Twitter, what people wrote. I didn't have many followers, but I was really astonished by the many labs projects, how people manage to replicate so many studies and get some interesting results in that setting. And I asked my followers, what if we do something like that, but using EEG? Nothing fancy about this idea. And I didn't expect any response, but I was blown away by the number of people who actually offered their help and who wanted to do that in their own labs, wanted to try to replicate some EEG studies, started discussing what kind of studies we want to replicate, what kind of findings, because we discussed such ideas like, for example, P300 in oddball paradigm is not what we want to replicate. It's kind of well-known thing, but what we want to do, it was all to be defined. And it was this question and many others we had to answer in the next couple of years. After that initial response on Twitter, we distributed the sign-up forms everywhere possible on different forums. And now we have a network of EEG researchers connecting about 200 labs all over the world, including Russia, mostly from Germany, USA, and the UK, but there are a few labs basically everywhere except Africa. What we're trying to achieve in this project, what's it all about? Yeah, we already understood it. It's an international network of researchers. And what we want to do is to assess replicability of some of the most influential EEG studies. The EEG studies looking at the psychological phenomena. I think that this project can help us to improve rigor and robustness of EEG research in the future. And while we're doing this, while we're collecting this data, doing these replications, I think we can achieve some other additional goals. Like, you know, the most of EEG studies, most neuroscientific studies are an enterprise of a single lab. You plan your own study, you run your subjects, and you end up with 20 to 30 subjects, try to make sense of it, publish a paper, and that is done. But if you look at the power of your study, in many cases, you just can detect only large effect sizes. And I think that just this, by showcasing that it is actually feasible, it is possible to do like better science, more powered studies using EEG, it can be of value at least. Since most of the studies we've already selected are using the most common ERP paradigms, I think it is also possible to provide the EEG community with informed effect sizes. Because now if you want to properly power your study, you look at the literature, you look at single studies similar to your study, or you look at the meta-analyses, which are normally biased. You get this effect size, try to power your own study, but actually you don't know the real effect size because the previous studies are not reliable enough source of information. We also want to create the largest open access EEG dataset in history, because if we join forces with 200 labs and each lab collect a reasonably large sample, and we share it openly, I think it can be of tremendous value for many researchers who can either cannot collect their own data, or they want to test hypotheses without collecting data. And of course, we want to add some information to the replicability of published EEG research, because now this data is not just limited, it's basically non-existent. We just don't know anything about replicability of EEG. And now the question, what kind of studies we want to replicate? Maybe we should follow this approach that reproducibility project psychology followed, to just sample random articles from certain journals and duplicate those random articles. We actually think differently. We think that any replication attempt should balance the potential impact and the amount of resources this effort would consume. So we don't want to replicate just anything, but it should be something influential, something important. And what is this impact I'm talking about? First thing comes to mind if we're talking about impact is the citations, number of citations, the study, the article has accumulated over the years. And it is what we did the first step. Actually, did a systematic search in databases and selected about 1,000 of the most cited articles using EEG. But not only, we also asked people, EEG researchers, whether they can nominate the study of their choice, the study that they think is influential enough to be replicated in this multi-site study, multi-site setting, but it can be a study that hasn't accumulated enough citations yet, but it is influential enough to be included in such a project. And what we got in the end, we got 268 studies in our long list, but it was still long. We couldn't run 268 replications. And at the second step, we asked people who signed up at the time, 158 labs, to vote for their favorite studies, for the studies they would replicate in their own lab. They think that they are worthy, that they want to actually put some effort and resources into this replication. Half of these labs ended up voting, and we got a sample of 32 studies with 8 or more votes. 32 because we want to end up with at least 20 replications, and it was some kind of reasonably large number. After that is each of these 32 studies entered feasibility analysis, where we looked at the sample size estimations, we extracted some additional data, included a couple of studies on different bases, and ended up with 27 studies. What are these 27 studies? Here's the list. Here we can see the number of citations each study accumulated. You can see shortened titles of these studies. You can look at it on our website or right here. And this list contains 27 studies, but also 3 additional studies we first selected, but then not excluded, but moved them to a separate project, spin-off project, what I call it. What is different about these studies? These studies actually recorded resting state, EEG, and then looked at the correlations with some personality measures, you know, this alpha symmetry, frontal alpha symmetry studies, and depression, anxiety, mood, this kind of stuff. We thought that maybe we can do something better with that. And I'll talk about it a bit later in the end of this presentation. Here you can see word cloud with the most commonly used ERP components or EEG phenomena. And you can see that the ERN is basically what people wanted to look at. Most of these studies are actually looking at the event-related negativity. There are some P300 studies, like one study looking at this contralateral delay activity, for example, 2 studies looking at the alpha phase. So there are some oscillations, but mostly these are ERP studies. In order to make this effort actually happen, we thought that we need a good organizational structure, and the main idea of this whole project is that each of these elected studies, each of these 27 studies, will be subjected to at least 3 replications. Here's this many labs idea comes in. At least 3 replications conducted by at least 3 independent labs. Each of these studies will also be submitted as a registered report. So meaning that it's not just running a replication. It's a replication which is pre-registered and then passed internal peer review in our Emanus network, and also passed peer review before the data collection in the journal. And we're really proud to have this connection with Journal Cortex. They agreed to host our project, and they're gonna publish all these papers coming from the project. Each 27 or most likely less studies will be published there. Each of these studies will have a lead replicating lab, which is responsible for preparation of these registered reports. Here you can see the organigram of the whole project. We have this core team, these project coordinators, advisory board of EEG experts, and the lead replicating labs. Each lead replicating lab is assembling a team to run the replication of particular study, and there are at least 3 labs involved, the lead lab and 2 other labs. Before running this project, when I distributed this sign-up form, there was a question, unrestricted question about the resources in each lab of the lab, which would potentially collect the data for the project. We asked them how many subjects you can actually run in your study. Yeah, I understand it's really difficult to answer this question without other restraints, like in how long or what kind of subjects, you know, are they all just healthy young individuals or someone else? But all the people understood it somehow and responded in this way. So here you can see the distribution of the responses. And what we got a median number of about 50 subjects, which is really important because it is really helpful to plan accordingly each of these replications. We estimate the sample size for each of these 27 studies, and we found that the median sample size is about 45 subjects. So it's below this 50 number, which is really good. But you can see that there are studies requiring collecting like hundreds and hundreds of participants, which is impossible to do in a single lab. But we still want to do 3 independent replications in 3 independent labs. And here's the first approach: when you have like small enough sample size which is feasible to collect in a single lab. The lab collect the sample from this data set, number 1, and then they provide the summary statistics for internal meta-analysis. Summary statistics meaning is just the effect size, because we powered each of the studies to test one single hypothesis. One statistical inference test should be enough to make this conclusion whether the study was replicated or not. So we have, for example, 3 effect sizes. We combine them in this meta-analysis, and if the p-value is below certain threshold, means that the study was replicated. We have another approach. This is exemplary study number 2, where we have really large samples. It's infeasible to collect in a single lab, and it means that a couple of labs, several labs, can actually join their forces and collect one data set, which will result in another effect size, and then we do everything like in the exemplary study 1. But here we require the participating labs to have certain similarity in the equipment. So at least the type of amplifier in the electrode should be the same. Here you can see some very optimistic single study timeline. Most importantly, what you can see here is that most of this time is dedicated, not most, half. Exactly, half of this time is dedicated to the preparation. When we identify the study lead, we get enough labs to participate. We prepare the stimulus, presentation, scripts, we develop the data analysis protocols, we collected some pilot data, submitted the registered report, and it is only half of all of the timeline. So the data collection is not the longest. It's not the most problematic and longest step, actually. It's difficult to predict how long exactly this study will take, but in a number of years, hopefully in 3 years, I want to see these 20 studies, at least 20 studies, were tested on replicability. We created a repository of analysis pipelines because we want to share all the scripts, of the analysis scripts, of the presentation scripts as well. People can take a look and maybe adopt this analysis in their own labs later. We've got a large database of EEG recordings, and our estimation that it is going to be about 5,000 recordings. We've provided better solutions for cross-laboratory data harmonization. What I mean by that is that this idea that we actually want to play it safe. We want to collect data set, then get the effect size, and then only the effect size, these second order statistics, will actually be used to make the final conclusion whether the study was replicated or not. We don't use the raw data, but actually want to use raw data. Yeah, it gives us more freedom, more flexibility, but we don't know much about the differences between different equipment, whether we can actually do that or not. Yeah, that's what we want to understand better in this project as well. And of course, yes, we get these effect sizes of the most common ERP paradigms, like ERN, or feedback-related negativity, P300, that people in future, while planning their own studies, will get a better idea of what actually they can use as this minimal effect size of interest. And that is about this main project. And I promised to tell you a bit more about this spin-off project called now Emanus Symmetry. In this sub-project, we want to explore the relationship between personality traits and resting state EEG. Yeah, I know. It's a controversial topic. With the main focus on frontal alpha asymmetry. What's problematic about frontal alpha asymmetry and about all these studies? The thing is that the results are kind of inconsistent. So since the 90s, I've had multiple replications, normally small-scale replications of those like depression and alpha symmetry correlations, multiple non-replications. But you know what? The original studies are cited like thousands of times, but the replications are almost immediately forgotten, like they never existed, actually. I think we can do something with that. We can solve this problem once and for all. Yeah, hopefully. Yeah, here's this studies, like among others, is what we've selected and what we want to look at, like the difference in alpha symmetry and emotions, like a mood, this behavioral approach and inhibition systems. All these studies have been cited like 1,000 times, at least hundreds of times. And what we're going to do, we're going to take two approaches. First approach is that we collect some resting state data before every of these replication. Currently, we've decided to record about 5 minutes of resting state with closed eyes. Administer these questionnaires before each of the recording and after the main session. But the second approach is a bit different. While we're collecting all this data, it's going to take really, really long. But you know what? I don't know how about you, but over the years, I've been collecting this resting state EEG in almost every single experiment, but never used it. It's just sitting on my hard drive without any use. And I know many people who actually have the same kind of problem. It's not a problem, like having the data is not a problem. It's worse than when you don't have enough data. But it's practically useless in many cases. And I asked people in our EEG main lab network in BioDat, what they think about the idea if they donate their data, and we try to run this sub-project together, maybe publish another paper, check, upload all this data, make it open access and everyone can use it, along with sets of questionnaires and some cognitive tests if available. At the moment, we've received responses from not many, like 15 to 20 labs, and they're willing to provide us with at least 2,000 recordings. About 300 of them were already uploaded, but it's gonna be larger, I hope. Maybe you can upload your data. Yeah, at least register your data set first. Here, we're not asking for just to upload your data immediately. You're just asking to register whether you are interested in this initiative. You can do it here. And we also have the second spin-off project, and this one is like just on the level of an idea. So we haven't started anything here, but I would be interested in discussing this idea. In most of the studies we're going to replicate, people use visual artifact identification and rejection. So you got your data into epochs, you find like an epoch and apply some subjective criteria and see, oh, it's an artifact, I want to exclude it. It's just good, it like works. And in my personal opinion, I think it works much better than current automated analysis pipelines. But it's just my own opinion, and there have been almost no studies, like really small scale studies, like comparing these two approaches. Whether we do it old school and just look at the data and select the independent components which are related to artifacts, or we reject some bits of data on this visual criteria, or we use some automated algorithm. What is better? Whether actually this application of automated algorithm, which is reproducible, is actually it can actually improve the replicability. So I hear it all the time. Oh, these automated algorithms are reproducible, but I'm not sure about it. Like reproducible shit is not really a good thing as well. Yeah, I would be interested really to discuss this idea as well. So that's what we want to do. We want to compare. We most likely most of the studies will use this manual artifact rejection algorithm, manual artifact rejection, just because the original studies did that. And then we can apply some algorithms, artifact removal, and compare two approaches. That's the idea. And in my last slide, I want to just thank everyone who has been involved in this project so far. There's been really many people who helped to make it going. And there will be many more, I'm sure. And here, I want to thank you for your attention, and I'm ready to take questions. Should I stop? Sure.
Thank you very much, Yuri, for very exciting talk. So now I would suggest, yes, we can everybody now ask questions. You can use either chat or you can raise your hand using reaction button. Just press reaction and raise hand. And maybe first you can ask questions about the related to this presentation directly, and why then on wider topics, or maybe related to the, if you have read the these publications in Cortex about some details of the project. But of course you can also be free. Okay. So maybe I've asked the first question. If there will be at the same time when you are working on this project, some other research which are not related to not connected to this project, but on very similar topics also related to replications on maybe the same experiments or the same results. I'm going to maybe include them to a common database, so somehow treat them, or what will be your approach to such different studies?
So you're asking that if someone completely unrelated to the project just did the replication and
on similar kind of replication.
Yeah, good. Go for it.
No, I mean, I'm going because there are quite many of these topics are investigated. Just people following their own way of research, and of course there will be at the same time quite many similar studies. So it will be just
I would be interested in looking at these other replications because interestingly, so out of these 27 studies, we've got 2 studies with some replication attempts ready. They used really 2 small samples, but still they count as replications, and we're not going to exclude them from our list of studies. So it's just additional verification, but they've done it independently, and yeah, we're going to cite them maybe.
Yeah, thank you. And now I see Boris raised hand.
Okay, so it's really a great idea to evaluate the effect sizes and the need to recruit a certain number of participants. That's really fascinating, but I'm not sure I understand the very idea here, how you can have a general solution to all research questions. I mean, that you can have a basic research question. For example, if a certain phenomenon exists, like most of such phenomena were discovered 50 years ago, like P300 or ERN. Okay, they're very robust phenomena, so you need just a few participants to be sure that these phenomena exist. So a very strong effect size. But then you generally try to compare conditions. So you play with experimental conditions, you play with different groups of participants, so you may compare men and women, you may compare older versus younger, you may compare different probabilities, different certainty, and so on. And the closer you get your conditions, your comparisons, the less will be the effect size. That's like you compare children against elderly people, great difference. Then you make it closer. You compare like 20 years versus 40 years, smaller effect. And then you compare like 20 years versus 21 year, just 1 year difference. Probably no effect, you will just lose it. So how can you solve this question in general? Because the very answer depends upon the research question.
None of these studies we selected are just looking at ERN that it exists. It's not the question. They're looking at the different moderators of ERN. For example, whether anxiety levels can moderate ERN, or they may have some other different questions. Yeah, if you look closer at those studies, you will probably
okay, but I still wonder how you can do it in general.
Not exactly do in general. It is, yeah, if we get this collection of effect sizes in, for example, those about 7 studies, I think, using ERN, and you can see how the ERN is moderated by different factors, maybe get some idea of the mean, like what is the mean effect size for ERN itself, and how different moderators, such as anxiety, can change it to make it smaller or larger. So yeah, the effect sizes, these effect size databases, yeah, we can look at the main effect, like the ERN, this large sample, different individuals, but also we can look at the different moderators, including such moderators which are not related to research design moderators, like technical moderators, like the type of amplifier, something like that.
Mm-hmm.
So Elena raised a question. Elena, please switch on your microphone.
Thank you. So thank you, Yuri, for interesting presentation. So my question is about methods you're going to use. So this is EEG replication studies, yes? But for example, all studies like alpha symmetry studies, they're really old, so we may use some not optimal methods for calculating alpha symmetry. So are you going to use the same methods, or are you going to use more modern methods? And for example, EEG, it can also be used for alpha symmetry studies. So what do you think?
Our question is that we have we just divide the paper into two parts, basically. The confirmatory part, where we use everything as close as possible to the original design. Mm-hmm. And then there's some exploratory part, where we can use the most modern methods. Maybe we can use the multiverse analysis, applying like dozens of different methods to get to the same point where we get this alpha symmetry score, and compare all of that with it, and compare look at the number of replications and non-replications in different using different methods. So there was a paper published like 3 days ago on using this approach with alpha symmetry. Yeah, mm-hmm. I think we can do something with that.
Because I remember reading the paper about alpha symmetry in some infant sample. They reported that frontal alpha symmetry was correlated with the opposite occipital alpha symmetry. And it may depend on specifically on age of this population, because they don't have frontal alpha, but they have occipital alpha, and this may be just another side of a dipole that you see in the opposite hemisphere, things like that. So you're specifically looking at adults, yes? Or...
Yeah, exactly.
Mm-hmm. Okay, thank you.
Yes, Tatiana Alexandrovna, please. Please switch on your microphone. Yes.
Thank you very much, Yuri, for extremely interesting presentation. And I much appreciate this brave attempt of self-reflection and of look at the so-called replication crisis in psychophysiological research. And these, for me, this raises the more principal question: what is the reason for these replication crises? And just if I turn to the previous question about alpha symmetry, just as an example. So there was a very interesting meta-analysis that was done in 2017 about the relationship between alpha symmetry and depression. And the answer was there was no, relationship according to these meta-analysis between alpha symmetry and depression. And this statement of this relationship is the so-called cornerstone of alpha symmetry research. And I remember my talk with my colleague and friend. She worked for many years in Robert Davidson lab, you know, the founder, so-called of alpha symmetry topic. And she told me, you know, it's a very strange results, because if you take, for example, a small sample, no, say 25 subjects, you will have alpha symmetry and you will have your relationship with, you know, the questionnaire of depression. But if you make the sample size bigger, for example, if you take 150 subjects, you will lose your relationship between alpha symmetry and depression. So it's very strange dependence on this correlation on sample size. What do you think about this relationship, this strange relationship, and this strange dependency? It might be that the correlation exists, correlation does exist for subsample, but when you are trying to increase your sample, you just are losing this correlation. And we don't know really the reason why we are losing it. Just it doesn't mean that it doesn't exist. It means that it exists for some people, for some for some special types maybe of personality. I don't know. That's a question. Does increasing the sample size solve all our problems with replicability crisis? And we just, you know, throw out the child with the water?
It solves most of the problems, yes, along with the with more transparent reporting and publishing new results. So it's, yeah, there are many different problems, but because I cannot believe that you can get something reliable in a sample of 20 subjects with correlations. It's just underpowered under any circumstance. There, any like psychological phenomenon correlated with any like brain measure.
Yeah, I agree with it. Absolutely.
Like, it cannot be larger like 0.4. I think 0.2 is like better estimate of this correlation potentially. But you cannot get anything reliable with such sample. But if you collect large enough sample and look at, you can test your hypothesis. Like, or if I take like a small sample and run this correlation, yes, you can sample like smaller groups from this larger sample, like 20 subjects, and run your correlation and to repeat it again and repeat it again and multiple times and get test your hypothesis about these special populations and their correlation between frontal alpha symmetry and some kind of personality measures.
So with these meta-analyses, we we can say that regardless, you know, regardless the exact characteristic of the sample, first, regardless the exact, say, emotional state of our subject, because each lab, you know, has its own approach how to treat subject that came to this lab, that come to this lab. Regardless, you know, the luminance, for example, in the EEG chamber, regardless many factors that are involved, you still have this correlation. What is the question that you are trying to answer? Regardless the method how we calculate, for example, this alpha symmetry, the question that Elena just addressed, because maybe the method how you calculate this alpha symmetry is incorrect.
Yes, and you can easily test this hypothesis. We also want to record every peculiar detail about the lab setting, about the environment, about the university, and all this stuff. And yeah, you can build a really huge model and trying to predict the alpha symmetry and check whether different personality traits like the mood, so we want to measure it as well, can actually influence alpha symmetry, or with multiple different other personality traits, different other predictors. Yeah, you can do that.
Okay, so we can add another predictors if we know with them,
and
if we can measure them, right? And then add to your model. So I mean that you should know a lot in advance in order to correctly run these replication studies. Otherwise, you will just answer the question if whether these relationships exist regardless any other possible factors that can influence it. This relationship between
alpha you can control for just every single factor possible, but you can put into your model everything you think can matter, and most importantly, you can account for these factors which the original authors think are important, because we are in close contact with them.
Yeah. It's interesting because I have just looked at the meta-analysis of gamma studies in autism, and I was really surprised because this meta-analysis was based on, a number of studies that were performed in different labs, and they just used slightly different stimulus parameters to induce gamma response. And they came to conclusion that there was, no difference between autistic subject and, for example, young healthy subject in gamma response, but maybe it just the consequences of the dependency of gamma response of the exact stimulus parameters. And when you started to vary these stimulus parameter, you will vary your results.
Yeah, that's why we need replication studies, exact replication.
So in this case, this Brave project that you just launched, it's much better than literature meta-analysis. At least you can exactly control, the parameters of the experiment that you know about. Yeah, thank you very much. I think it's very interesting endeavor.
Okay.
Yeah, I see Olga Sisoeva raised her hand.
Yes.
But just before, may I ask Yuri, just related to the previous questions. So probably if there will be several labs will not replicate some effect, and one lab will replicate. Maybe you already mentioned, I just missed. Do you have some algorithms what to do in this case? So would you try to run additional replication, for example, using conditions very close to this lab where the results were replicated, or no?
Yeah, we're not planning to do that within this project. So we're looking at the internal meta-analysis results. So it is not just possible, it will happen, and happen pretty frequently, that our 1 out of 20 out of 10 labs will not will replicate, and the others will not replicate. So it's very possible. It happens each time when you run a multi-site study. Yeah, we just measure the effect sizes, and Yeah, weight them.
But it can be not related exactly to the variability, and so effect size is slightly different. I mean that it can be that very random variability. I mean, but the such difference can be related to the difference in specific conditions. So it will be could be not only random, but related
Yeah,
to
that's what I meant.
some laboratory, some lab will.
Of course, yes, but it is like the first step. And then you have this open database with all the EEG data, but not only, with multiple different moderators, including, as I said, like environmental variables, including stuff like the level of training of the research assistants, or how they're trained. When you can go deeper and find something, if you like. Yeah, but we're not gonna do that within this project. I mean, at least not within this single studies registered reports. Maybe later in the last publication, where we just combine all the data from single replications and check it and look at the moderators.
Thank you. So, Olga, please.
Okay. Hi, everybody. I also want to comment a little bit on the issue just raised. That indeed, the thing is that sometimes some experiment is not replicated. It doesn't mean that it's not reliable or it's random. Because, for example, in physics, there is some laws that we know that they hold. But, for example, in practical sessions in schools, we not every time can replicate this common physics law, because we can't control a lot of parameters, and so they're making the kind of the condition and parameters very pure and identical between the labs and everything. So it's important, and I think it's good project and good idea to try to do it. But certainly also the non-replication sometimes is not like indeed the huge sign, red sign. It's probably that we need to kind of find the exact parameters and tune the approach. And to this end, I also have the comment that even what we recently found, that even the way how the people correct artifacts is not uniform between the different labs. And how the people do ICA, or they do some other type of analysis and extract eye blinks. And sometimes with extracting eye blinks, you can also delete, subtract some brain activity, and which algorithm for artifact correction use. I think that is also important issue, and which is very subjective to one side. And to this we now collaborated with Skolkovo guys. It's Maxim Sharayev, Alexander Lidovsky, and together we now made the open source toolbox called Alice, which kind of aims to also to have open source database of EEG data, which experts can use to subjectively identify artificial ICA, for example. And then the Skolkovo group, using the machine learning techniques, they want to write a particular algorithm, which will be then objectively kind of clean EEG data from the artifacts. And certainly, it's now only the beginning of of this toolbox. It was just launched. But when I was listening to your presentation, I was thinking that this two projects can be somehow combined, as far as you will plan to have a lot of EEG data, and these guys, and like together with us, like, because we are just providing them EEG and helping to kind of do some meaningful neurophysiological work, but to find the algorithm for and to test the algorithms for automatic artifact detection. What do you think? Do you think there is a way to collaborate on this?
Yes. That's the idea of this second spin-off project. Yes, to check.
So then like then we can probably you can check this Alice toolbox and
yeah, I've seen it.
Yeah, and we can this Skolkovo guys, and then we'll be because we are not just messaging in Telegram, so they are not present here. So I was kind of a voice of them here. So then, so that would be probably nice. So they probably will be contact you soon or somehow.
Cool. Yeah, I can write you afterwards, and we can discuss it later.
Okay. So and I see Boris raised hand.
Okay, I just have one small comment, maybe a question. So whether you are going to control this. So Tatiana already mentioned that you can have a small sample size and you have the effect, you hire additional volunteers and you lose the effect. That can be because different populations have different properties, like those scandalous studies that ERN are different in Democrats and Republicans, or ERN is different between atheist and religious people, or like data that I've heard many times that psychophysiological data are different in European population and in Chinese population, like racing state data, for example, just because probably it's different mental transition in Europe and in China. So replicability may depend upon what participants you hire. Even if they are the same age, they may differ in political views, they may differ in, for example, results. I'm sure results will be absolutely different if you hire students from social sciences or students from mathematics or physics. They have different cognitive properties and results may differ. That's just a comment and a little bit of a question whether you are going to track what participants are recruited for studies.
Of course, yes, there's standardized demographic questionnaire. So we're collecting all this data. Of course, the place of origin of these participants included. And actually, this modular study about the liberals and conservatives is also in our sample. And of course, we know that if we want to try to replicate it, we need to replicate it in the same exact population in America, certainly not in Europe, not in Russia. Yeah.
Okay, more questions? So maybe questions for more general topics like replicability of brain research in general. And so maybe one question then from me again. What's your opinion of the statistical tools we have now for such studies? Are they sufficiently good already, given the huge degrees of number of degrees of freedom and so on in brain data? Or maybe we still need something new, and maybe use even in such large-scale projects, it'll be still easy to miss something important, and maybe we will have to look more for new statistical tools.
Yeah, it's reselected. The studies only where you can test the hypothesis with a single inference test. Yeah, the t-test or no, or something like that. That is true, and it is probably an outdated approach in the new studies. Probably we need to go look into this direction of machine learning and multivariate statistics. Yes, I agree that it can potentially do some good, but also harm research. I don't know. Yes, yeah. In my studies, yeah, I always have this question. I have 64 channels, and I know that one of these channels is actually like where I want to look at this particular component, and the other channels are just really useful. But I don't want to discard them. I know that they contain some information. Yeah, I agree that we need to develop new statistical tools for such multidimensional rich data as EEG or MRI.
So, any more questions? Okay, so maybe we will now finish. It's slightly more than 1 hour. So or maybe somebody wants to say something in addition, like some discussion or some opinion. Okay, so I think it's really great project. We both really need this time of development and of this. Maybe it was needed even before, because there was so much confusing data in this EEG research, maybe more than in any other type of brain research. So I would like to wish you great success to this project. But I see there is one question from Ivan Gerdev. Yes, in the chat. How do you share raw data sets?
So because
gigabytes.
It's not tens of gigabytes, tens of terabytes rather. Yeah, it's been in discussion. So we have multiple approaches. First, one is that we have an agreement with German, it's called in English, Psychology Institute. They have resources to store like unlimited amount of data forever, basically. And if it is not possible for a single particular lab to share the data on this data server, we have some restriction, ethical consideration. They can share their data on their institutional repositories, and then we will use this distributed data repository approach. And you have like one place where you can access every single data set, but it's not located in one place. It's located, it's distributed over many repositories all over the world. Yeah. Ideally, we would love to like store it in one single place, but realistically, it's not going to be possible.
Probably there also can be some different ethical regulations and
exactly.
And
yeah. Basically, like in New Zealand, you cannot share your data, so it's just you learned it recently. Yeah.
Yes, and there's one more question. Maybe you will read it in chat. So I'll also read it. Isn't it correct that replicability depends on obtained dataset quality? In these terms, it's be nice to rely on standard approaches such as neurodata without borders. And there's some link.
Yeah, I will look into it. I don't know what it is. Data without borders. Is it data standard? Yeah, the data sharing standard is bits in our case, if we're talking about the data standard. But the quality, yeah, we're doing everything possible to equalize quality of the data in different labs, including video recordings of the data collection procedure, like in every single lab. But I don't know what else can we do. Advise us.
Okay, one thing I wanted to add is that actually it's quite very different from this talk. I see one question, but I'll finish first. I actually first met Yuri at conference in Moscow, as poster cognitive conference, very unusual format. It's only poster based, and Yuri came from Ural to Moscow to this conference. It was very nice to meet him. Several probably conferences in a row. And so this conference will be next month in June. So there will be, it will be offline, and there will be very strict measures taken against coronavirus, but still possible to meet in person. And if you will be, ask everybody, if you will be in Moscow, please come. And you'll see that it's, if you don't know, still this haven't been at this conference, there are also a lot of EEG research usually presented. It's really, really nice, really nice atmosphere. And you just can find in internet just a poster cognitive conference Moscow. But it's mainly in Russian, but if you are in Moscow but speaking English, you can also find people to talk with him.
Yeah, now I'm sending my students there, so find them and ask them questions.
Yeah. So this new question from Ivan Zherdev: is your project affiliated with replication.net.com?
No, it's not. It's the first time I've seen it. It looks like it's some kind of economics related project. I don't know. No, I'm not familiar with that. Sorry. But I'll check it out.
Okay. So probably now it's time already, unfortunately, to finish, but it was a very, very nice meeting, and I would like to thank you, Yuri, very much for really very exciting presentation and very exciting project, first of all. And I also ask all participants, everybody who came to listen, and the video will be posted on YouTube channel of Mac Center Moscow, and maybe Yuri could also put a link at EEG Lab account at Twitter.
Yeah,
yes. Okay. Thank you very much.
Thank you. Bye.
Bye.
Okay. Thank you. Goodbye. Thank you.